This is Chapter 2, Lesson 6. We're going to talk about special functions. One special function is called the piecewise function. And when you hear the word piece, that's exactly what this function is made up of. Two or more pieces or parts, expressions that will graph two different things. So normally you'll have a break in the graph or some kind of gap, something that you have to pick up your pencil and start again somewhere else. So let's talk about how to graph that. If I have a piecewise function, this is what it looks like. These two things are my expressions, and these are the rules that I must follow. So here it's telling me that if I pick any x values or any input values, they must be less than or equal to 3 if I want to create this line. So I'm going to go ahead and plug in 3. If I plug in 3 to this expression, it would be 3 minus 1, which is 2. So when I plug in 3, I get 2. And notice that because I have the equal sign, when I go to graph this point, I want it to be a closed circle. So I'm going to go to 3 and then up 2. Closed circle. Now, this tells me that I can use all the x values that are less than 3. Okay, I already have the equal to part. So less than 3, I'm going to do 2. And if I put a 2 in here, 2 minus 1 is 1. So at 2, I get 1. So at 2, I graph 1. Okay, and then at 1, when I plug it in, I get 1 minus 1 is 0. So at 1, I'm at 0. And this is going to continue because this is a linear expression, a linear function here. It's going to continue going down 1, 1. So I can keep making this forever and ever that way. And when I connect, you don't want to go through the point at 3 because this specifically tells me that only the numbers that are less than or equal to 3. So I got to stop at 3. Okay, so that's only that part of the function. Now I need to graph this part. Well, if you look at this, there are no x values. Basically, this says no matter what you plug in for x, your result will be -1 for all the numbers that you would try to plug in that are greater than 3. Okay, so at 3, there's nothing to plug in. I just get -1, but it's not equal to. Since it's not equal to, when I go to 3 and I get the result -1, I need to put an open dot. So this is 3, -1. Now, if I put in any other numbers that are greater than 3, so 4, again, there's nowhere to plug it in, so it's just -1. So if I plug in 4, I get -1. At 5, I'll get -1. At 6, I'll get -1. And this will continue on and on for all values that are greater than 3. So we stop. You don't want a closed circle there. You don't want a closed circle here because this could not be equal to the 3. So we have an open circle there. All right, and then it goes on forever and ever as long as your x values are greater than 3. So that's what a piecewise function looks like. You just have to graph it in parts. Absolute value functions are also special types of functions. And I'm sorry, it's a little blurry on my page, but it looks pretty clear through the camera. So what you do with absolute value functions is plug in some values. First of all, the absolute value function will create a V shape. And when we get into quadratics, you'll need to not get this confused with the quadratic, which produces a U shape called a parabola. This one has a point. Okay, so if I plug in -3, -3 minus 2 is -5, but the absolute value of -5 is +5. So at -3, I have +5. at negative 2. Negative 2 minus 2 is negative 4, but the absolute value is positive 4. Negative 1. Negative 1 minus 2 is negative 3, and the absolute value of negative 3 is positive 3. 0. 0 minus 2 is negative 2, but the absolute value of negative 2 is positive 2. 1. See, we tried some, you have to be careful here because it creates a V shape. If you're only creating a line, that means you haven't made it to the vertex because you need to be able to change directions. So I want to keep going until I change directions. We're going to plug in 1. 1 minus 2 is negative 1. And the absolute value of negative 1 is positive 1. 2. 2 minus 2 is 0. And the absolute value of 0 is 0. Hopefully we'll change directions now because I've just been going in a straight line. 3. 3 minus 2 is 1, and the absolute value of 1 is 1. So at 3, we're at 1. Now we've changed directions. If you plug in 4, you'll get 2, and the absolute value of 2 is 2. And you can continue this method. At this point, because I can see the shape, I'm going to go ahead and connect. And make sure you make the V shape. This function does go on to use all x values. So you want to make sure that you show arrows at the ends of your V shape because it doesn't just stop where you stopped choosing values. Okay, let's look at this one. Now be careful because the negative is on the outside here. So no matter what you take the absolute value of, you're going to make that value negative. So if I plug in 0, we'll start with 0, you'll get 1 because absolute value of 0 is 0. There's not a negative 0. And so 0 plus 1 is 1. Okay, if I plug in 1, the absolute value of 1 is 1. Absolute value of 1 this equals 1. So if I have the opposite of that 1, which becomes negative 1, and now I have 0. So at 1 we get 0. Well, let's try at negative 1. Well, the absolute value of negative 1, if I put in the negative 1 here, would still generate a positive 1 here. And then I'd have to pull this negative back down again. So I still get negative 1 plus 1, which is 0. And you can see the shape there already. But let's just go ahead and give it a couple more points. Negative 2. If I plug in negative 2, I get a 2 for the absolute value. But then it turns back into negative 2. And negative 2 plus 1 is negative 1. So at negative 2, I am at negative 1. At positive 2, absolute value of positive 2 is 2. This makes it negative. And negative 2 plus 1, again, is negative 1. And then we can connect. Again, make sure you put arrows on the ends to show that it continues in both directions forever and ever. This is all for 2-6, and come see me if you have any questions.